Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Zeiss. I think you should go to Zeiss.
Zeiss Digital Partners.
Be amazed of knowledge, industries, manufacturing, optics, hardware, software,
AR, VR,
Machine Learning,
infrastructure.
Ich will nicht aufstehen und irgendwie mir denken, scheiße, ich muss meinen Job machen, sondern was kann ich heute machen?
You will make it happen. Do it.
Hello, everyone. Now, I'm a little bit curious because we're going to be talking about performance optimization. I want to know from all of you who here, not necessarily just for you, if you're like a back-end engineer, but maybe your front-end team, who here uses a front-end framework, one that might be perceived as heavy, something like Vue or React or Angular or something like that? Yeah, so most of us, right? And who here has done some kind of like server-side rendering to make sure that that's a lot faster? So like half of that, I think. And for those of you that didn't raise your hand but did raise your hand before, who of you is dreading to implement the server-side part? Nobody? One person? Okay. Who is looking forward to implementing the server-side part of that? No. Oh, no, the same person. Good, good. So we're going to be talking a bit about that. We're going to be talking about offloading everything from the main thread. For my work on our web, I recently ported a bunch of stuff to a web worker, which stopped people from dropping frames, which is super annoying. It wasn't fun work, I have to confess, so I'm really looking forward to seeing the tools that we have up next. We have an absolutely amazing speaker for you today. He is the CTO of Builder.io. You probably know him as the creator of Angular or Qwik. And he's going to be talking about Qwik and Partytown, which he helped create. And we're going to be talking about offloading 99% of JavaScript from the main thread. Can I please get a huge round of applause for the one and only Miško Hevery! Thank you. Good luck.
Thank you. Hello, how's it going, Berlin? So, I thought maybe we could talk about Qwik. So let me do a very, very quick introduction. So, hi, I'm Miško. Already the introduction was given. I'm a CTO at Builder.io. And we want to make web fast. So let me just give you a very quick 15-second explanation of Builder, what Builder does, because it ties in to why we care about web being fast and why we're building Qwik and Partytown. So let's say you have a website, like one on the left, and the marketing department comes and says, we need the website on the right. And this happens all the time, right? There's always changes that needs to happen. And so you could go and you can change your website with something like this. Problem is, these kinds of changes, they never stop. They'll be happening all the time. And so most people integrate some kind of a CMS system. Problem is that even if you integrate a CMS system, you will have issues that the marketing will say, now we want to make things bold. Now we want to have 2 cells going on. There's always going to be something that the CMS systems won't allow you to do. And so you can install Builder, you can cut the content over here, register the product component, and you can give your marketing department a editable drag and drop editor for the website. So most of our customers are e-commerce customers. And one of the things that really matters for e-commerce customers is to make things fast. And so our goal at Builder is to make sure that our customers' websites are fast, and we want to do it in an open source way. So we're working on this new technology called Qwik. And Qwik has a very, very simple goal, which is that it wants to make sure that no matter the complexity of your website, you should be able to get 100 out of 100 on a Google PageSpeed score, right? So the thing that Builder, what Qwik wants, is to make sure that your website is quick. So compare the website using Qwik on the left versus the one on the right versus the one on the left. Notice how much longer it takes for the existing website to go gray. Gray means that all the JavaScript is finished recording. And that's the particular thing that we want to solve. We want to make sure that any website can just become super fast. Okay, so why do we want to do this? Well, there is a lot of evidence that basically says the faster your website is, the more money you can make, right? If somebody says, I found this amazing shoes, and they tweet the link to the shoes, and you click on it, and the e-commerce site takes forever to load, at some point you're like, you know what, I really don't need those shoes that much, and you can just go somewhere else, right? And so Google has compiled a lot of evidence that basically shows that if your website is fast, you'll get better conversions rate, more sales, and so on and so forth. And then Google themselves actually built this thing called Google PageSpeed. And the idea behind the PageSpeed is that it can look at your website and tell you how performant it is going to be on a mobile device, on maybe not the best network, and how long it's going to take to load. And so all of this thing comes down to basically make the fastest possible time to interactive. And if you look at the internet, right, you're going to see that pretty much any website will get pretty bad performance numbers. So for the most websites, for the most of the web, everybody is in the red. And few people that can really afford to put time and effort into it, they can maybe get into the yellow, such as Amazon of the websites, right? And so why is that? Well, the answer is kind of obvious. The answer is JavaScript. And that is that if you look at the amount of JavaScript that existed inside of our browsers, inside of our web pages, it is steadily increasing. And there doesn't seem to be any slowing down that's happening. And there are people who say, well, it's the same website we had 10 years ago. But I will differ. I think the websites of today are way more complicated, way fancier. They can do a lot more stuff than what you could have done 10 years ago. And so the reason we actually have more JavaScript in the browser is because our sites are actually more interactive, more powerful, cooler websites. And so I don't see this trend stopping. I think this trend will continue. And so the question becomes, how do we get better at delivering JavaScript to the browser, right? We need this JavaScript, and the amount of JavaScript is going to increase. We need to get better at delivering it. And so to kind of point out that it's the JavaScript that it's the problem, we have this this thing we call performance insights. What it is, you type in a URL for a website, and we run it through Google PageSpeed. So on the left over here, what you see is Priceline by itself gets 36. And then we go and run it through our image optimization algorithm, and what we get back is the same number. What that tells us is that Priceline did a fabulous job of optimizing the images, right? There's nothing more that could be improved over here. Same thing for CSS. But notice what happens when we remove JavaScript. Huge jump, right? 96%. We go from 36 to basically green, almost 100. And if you combine all of those together, you see that's pretty much the same thing. And so what this tells us is it's the JavaScript. We took the top 50 websites, e-commerce websites. We ran the same exact analysis on them. And again, what you see is that for the most part, as the industry, we are doing a fabulous job of optimizing our images, fabulous job optimizing our CSS, not so much on JavaScript, right? But because it's a systemic problem to everybody on the web, I'm going to argue that the problem is the tools. The problem isn't the developers, even though like we are tempted to just laugh off and say like, oh, slow website, clearly your developers are not very good. But if everybody's having this issue, then it can't be the developers, right? If you had some websites that were excellent in performance and others were not, then you can be like, yeah, well, maybe that company doesn't know what they're doing. But if everybody's having this trouble, well, then it's not the developers, it's the tooling. And tooling is kind of the problem which Qwik focuses on. So let me start with what the problem is. And in one word, the problem is this thing called hydration. And the way hydration works is that your server-side render your page. You're like, let's say you're going to Amazon or Target or Priceline, and so you server-side render the page. You send it to the client. Immediately, the page shows up for the client, so that's awesome. However, the page isn't interactive, right? What we want to do is get over here to interactivity. But in order to get that, we actually have to do a lot of things. We need to have the framework download all of the application, execute all of the application. This is represented by the really fat arrow over here. Compute the state of the application, run the render method, reconcile everything, and then as part of the reconciliation step, the framework reattaches listeners back to the DOM, and now our page is interactive. And this process is what takes a lot of time. When I showed you this video, and it took 8 seconds to get the system going, the reason why it took 8 seconds is because all of this JavaScript had to be executed in order to get interactive. And so what Qwik does is it does something different and unique, and we call this resumability. And the way this works is the same way. You start with SSR, right? You pre-render your content, you send it to the client, but here's where the difference is. While in the classical system, you bootstrap the whole application, with Qwik, you have this super tiny bootstrap piece of code, which is about 1 kilobyte, and it takes about a millisecond on a desktop to execute. So really tiny and small. And what this allows you to do is go directly into the interactive mode. So your page immediately becomes interactive. And then once you interact with the page, depending on how you interact, different interaction require different code, we then download a little more code. And notice this arrow over here is not a fat arrow, it's a thin arrow, representing the fact that we just get the code necessary to process that one interaction and nothing else. So if you go to a e-commerce website and you say add to the shopping cart, then only the code necessary to take that item and add it to the shopping cart and re-render the shopping cart is downloaded. There is no need to download the comment section or anything else, or the menu section or anything else that's on a page. Okay, before I jump to a whole bunch of demos, because I bet that's what everybody wants to see, I'm going to take a little detour and talk about Partytown. So Qwik tries to solve the first-party problem, that is the code that you have written as an application. But every real application in the wild has tons of third-party code, right? You need Google Analytics, you need Facebook Pixel, you need HubSpot, you need Intercom, and who knows what else. You know, typical website has about 20 different third-party scripts on the page. And what happens is, not only is your application trying to hydrate and wake up and get ready, but also the third-party scripts are also hammering the main thread. And it turns out that all of this stuff is single-threaded, right? We can't do multiple threads on the multiple things in JavaScript, and so it creates a huge congestion. So what Partytown is some super clever code that allows you to move the third-party code into the web worker, right? And the web worker, it runs a little bit slower, but it doesn't matter because it's things like analytics and so on, right? It doesn't have to be the fastest possible thing. And in the return, what you get is you get that your main thread now only has to deal with the application rather than the whole thing. So a Partytown is a super simple thing to integrate. It will work with any of the existing stack that you happen to have, so I really urge you to go and look at it. But here we are talking about Qwik and Partytown is a bit of a kind of a detour. So let's go back to doing some demos. Okay, so when I talk to people about Qwik, the biggest problem I have is explaining the difference, right? People look at it and they say like, well, we already have React, Angular, Vue, Svelte. Why do we need another one? And the answer is because Qwik can do certain things that no other framework can do, right? So if you look at Angular, React, and Vue, what these frameworks are really competing on is on developer experience. Right? You really are just arguing like, do I like to write my template in JSX, or do I write them in a HTML file, or some combination of thereof? And you're really talking about the way you build the app. Qwik, on the other hand, focuses not necessarily on the developer experience, although we have a nice one. It focuses more on the whole experience of how to deliver the smallest possible amount of JavaScript to the client. So let's go to our first demo. So first demo is just a very simple hello world. And the thing I want to point out, that if you go to the hello world and if you look at the network tab, there is nothing there in the network tab. But that's unsurprising. Hello world doesn't have any behavior. So that in itself is not that exciting, right? The only thing that's kind of exciting about it is that, if you wanted to write a hello world, you would write it in what I would call the React style, right? Which you have a function. And inside of the function, you put the JSX describing what the thing should do, and that's kind of it, right? You ask it to render, and voila, you have your hello world. So now let's look at a more complicated example, and let's start simple with a counter. Obviously, it's a counter, so I can click on it, and you can increment the count. That in itself is not that interesting. What I want you to look at here is the network tab. And what the network tab is showing us that there is no JavaScript until I go and click on it. And when I click on it, it downloads two pieces of code. First of all, it downloads the handler, which is, in this case, upgrading the count. And after that, it downloads the JSX to re-render the component. So if you look at how you would write this, you would write it in this particular way. You'd say, I have a counter. It has some state, which contains a count. And I will display the count in here. And I have a button. And I have an onClick. And this is what you do when you want to unclick. Now, what I want you to think about now is this would be very similar code in just about any other framework, right? But the thing is, there is only one thing that you're exporting. There's only one symbol. And therefore, existing frameworks have to load this as a single thing. There are references, etc., and there's no way for existing frameworks to break this up into pieces. In Qwik, every time you see a $sign, you should be thinking, this particular thing gets lazy loaded. So there is a lazy loaded boundary here, and there is another lazy loaded boundary here, because we have two $signs. And so what's actually happening in a client is that this increment piece of code actually got pulled out into a separate file that got downloaded here. Now you might say, well, this is too much. I mean, clearly this is a very simple counter example, but imagine you have a huge application, right, where there's a lot of listeners, a lot of things going on. You need a way of breaking the application up. Now, the reason why this is hard is because what happens in practice is that Qwik refactors the code into something like this, right? We take the onClick and we make a reference, and we make this reference lazy loadable. Now, if you do that, notice what happens. Your store no longer refers to anything, right? The reason why existing frameworks can't break up the application is because, well, if they tried, they would fail because this store becomes, unreferenceable symbol. Like, you can't just do this. And so Qwik does something similar, something a little more complicated, and that is it knows how to there is some extra code here that the exact details are not important, but it can pass in the store here and then recover the store down here. And by doing this, we can now break up the application so that every single piece becomes lazy loadable, right? And so that's the kind of the basic primitive of Qwik, is that Qwik can take your code and break it up into lots and lots of small pieces. It turns out, once you have lots of small pieces, it's very trivial to put them together into bigger chunks. But the initial breakup is the thing that really matters. Okay, this is a super simple demo, nothing interesting. Oh, before I actually go on, let me zoom in on a couple of things. So how does this actually work? First, the code runs on a server, and what the server does is it executes it, builds up everything, no different from your basic SSR, but there is a difference in what gets produced. If you look at an existing SSR output and you look at the resulting HTML, you can't tell where the components begin, where they end, where the listeners are. All that information got lost in the process. And what Qwik does is it executes it on the server, but when it serializes it to the client, it actually saves all that information. So here we have our onClick, and it contains a URL where the code needs to be downloaded. Now this is a development build, so we have a long URL. In practice, it will be a short one. And we have a symbol where the what needs to be loaded, and then we have a special thing over here. This is how we restore, how we capture the lexically scoped variables inside of the closures and restore them. And so the question becomes, where does the 0 come from? And then here is the state of the framework. So the framework not only serializes listeners into HTML, but also serializes the full state of everything and into here. So in this particular case, it serializes information such as that we have an object called count, right? And this is how the system knows when you click on the button that we're starting from 0. We also have information about, like, if the component becomes invalidated and needs to be re-rendered, where do I download the JSX for that particular component? And finally, we have these things we call subscriptions. Qwik is a reactive framework, and it needs to have this because otherwise, without reactivity, it would be forced to re-render everything. And so what subscriptions do is they basically say, if the count changes, component 0 has to be re-rendered, right? And this is how this works. If I click, the count property has changed, and the framework knows, oh, when you change the count property, you need to go and download this piece of code, because that piece of code goes and re-renders the whole thing. Now, this is a super simple demo. Let's do something more complicated. So here I have a demo where it's also a counter, but it has an added feature called debounce. The idea is that I can click on here, and when I stop clicking and I wait 2 seconds, 2 seconds later, the debounce happens. Let me show you this again, and now look at the network tab, right? First click, we execute the initial set of code that we need. 2 seconds later, the code updates. So let's look at it on here. So we actually have 3 components. We have a top-level component called reactivity. Here, we set up our count and debounce count, and we have a watch. And watch is kind of a hybrid thing. It's sort of like useEffect, but it runs both on a server and a client, and it can keep track of things. So in this particular case, the watch keeps track of the count. It says, like, look, if the count changes, you need to call me. I need to be updated. And what the watch does is just sets up a timer for 2 seconds, and it copies the count to the debounce count 2 seconds later. And if the count updates before 2 seconds, the cleanup function executes and clears the timer, right? And this is what gives us this effect that as long as I'm clicking, nothing's happening. The moment I stop clicking, 2 seconds later, the thing updates. Now, when I refresh this on a server, let me do that. The server has to go, and it's not going to show me the top. This word over here says reactivity. I'm not sure why it's not showing me. Oops, let me try this again. It runs this particular part right here. It says reactivity. Okay, let me refresh this again. Okay, here's your reactivity. Then it ran the count changes, right? So then it ran the use watch. And then it rendered the child, because, well, we have a child. And the child simply takes the state and shows you the count. And it passes the state further into the grandchild over here. And then finally, we render the grandchild. So this all happens on a server, and the server really has no choice about this. All of this has to execute. But notice what happens on a client. When I click the button, it says the count has changed, then the child re-render, and then 2 seconds later, the grandchild re-render. What you don't see over here is the re-rendering of the top-level React component, of the reactivity component, right? So the system was smart enough to understand, like, actually, if you look at the reactivity and you look at the template, this particular component never changes. There is nothing that the user can do to cause a change and re-rendering of this component. And because of that, why should we change, why should we send the code to the client, right? We can just skip that. So if you look at the network tab will have incrementing of the count. It will activate the watch in order to do the debouncing. It will re-render the child, and then 2 seconds later, it will download the code for the grandchild, right? So there's a couple of things going on here. First, we don't have to re-render the components that don't change. We also don't have to, we can delay rendering of child components until we actually need to. And so Qwik is very surgical about the way it updates your UI. It wants to do as little as possible. Now, let me show you my favorite demo. This is my favorite demo. All it is a bunch of numbers, and at the bottom there's a clock that shows you the current time that is updating as you can see fit. The reason why this is my favorite demo is notice what's happening on the network tab. Once again, we got here no JavaScript, right? When I scroll the clock into the view, automatically the clock wakes up and starts processing and re-rendering itself. Let me show you this from the point of view of HTML. We have our div. We have our clock, we have our parts of the clock. Notice we have our hour, minute, second. None of this stuff is updating. The moment the clock scrolls into view, all of this updates, and this updates every 1 second. Now imagine you wanted to do this in your existing framework. Let's say you basically want to say, look, this is a super expensive component that I don't want to bootstrap until it becomes visible. How would you do that? You know, existing frameworks just don't have any primitives. Even if you try to do that. So let's look at how this works in Qwik. So we have a top-level component, and all the top-level component does is it, prints a bunch of numbers so that the clock is below the fold. So really, the whole purpose of this component is to just put a bunch of stuff on the screen so the clock isn't visible initially. Then we have our clock. The clock says, I need to load a bunch of styles. And oh, by the way, this happens on a server, and so when the clock wakes up on the client, it already knows that the styling has been loaded and doesn't need to load it again. We create a store, and then we say use client effect, meaning I want you to do this work, but only on the client. And the nice thing about the use client effect is the default behavior of it is to only execute when the component becomes visible, right? You could put an additional argument to use client effect that specifies different ways of doing it, but the default behavior is don't do this until it becomes visible. And then that becomes kind of nice because something that is really, really hard to do with traditional frameworks just is the default behavior in Qwik, right? And so the default behavior you're seeing here is that not only is a component, the top-level component, never downloaded to the client, the behavior needed for the child component only downloads once the component becomes visible. Okay, so I'm going to change gears now, and every demo needs to have a Hacker News demo. And the thing about that I like about the Hacker News demo is that so far we basically talked about Qwik as doing tree shaking in the sense that we don't want to download the code that is not needed just yet, right? We want to download the code only when it's needed. So the idea is we download the code, if we're downloading the code, we should be executing the code. If you download the code and you don't execute it, well then that's unnecessary download, right? And you should figure out a way of how not to do that. And the other thing to point out is that as a developer in Qwik, you don't have to think about it, right? There's nothing special you have to do to get that behavior because, well, it's just the $signs, and the $signs are part of the public API of the framework, so it's not like you even have a choice. Like, they automatically come over there, and what these $signs mean is lazy load all this stuff. Now, one of the problems that frameworks have is that they download data twice. Once, you download the data in the form of HTML, and then again, you download it in form of a state. So in the case of a Hacker News, right, the server went to the Hacker News JSON API and downloaded all the data, and if you did this on something like Next.js, this whole data object would be sent to the client in this humongous JSON at the very, very end. Notice what happened here in Qwik. The Qwik actually serialized nothing. The Qwik correctly deduced that actually there is nothing you can do on this page to modify that the components that are data bound to this data, and as a result, there is no need to send the data, right? Like, because the data never changes and the user can't edit the data, why are we sending the data to the client? It's unnecessary. And so Qwik not only tree shakes your code, but it also tree shakes your data. Now, let's look at something a little more complicated. Let's go into a specific comment, and notice now our state of the component contains extra stuff. And so the extra stuff it contains is that there is a child component right here that allows you to open and close the component like so. And this opening and closing is behavior, and this behavior is encoded inside of the state, right? So it basically says all of the comments are opened at the beginning. But if you look around, what you will still not find is you won't find the data that got data bound from the server, right? Again, the framework was correctly able to deduce that the data that we got from the server can't actually change on the client, and because it can't change, there is no need for it, and it gets thrown away. Okay. Now, every example also has to have a to-do app, so let me show you a to-do app. Now, again, let's go to the network tab, and now that this is a little more complicated demo, I want you to notice how every time I interact with the app, more code downloads, right? So I entered something, more code downloads. I check component, I delete component, I change the filter, I hit complete it. All of these are examples of downloading more and more behavior, right? So if you look at traditional frameworks, they download all of the JavaScript up front and execute it all to get everything ready. Qwik kind of flips it upside down, right? And says, actually, we don't need any JavaScript except for the tiny little bootloader. And then as you interact with the application, more and more code gets downloaded, right? So it's not that we're delaying the code. There's two things going on, right? We're delaying the download of the code, but not only are we delaying, we are actually downloading a much smaller portion of the overall application. Now, this is my favorite demo. Let's say you type something in here, and you add it into the list. This is what basic frameworks can't do. So once we interact with the application, the framework consumes the state of the application. But we can actually recover the state by calling pause on it. And if you look over here, me clicking pause will recreate the state object right here. Now that I have the state object, I can do copy outer HTML. I can open another tab. And let's go in here and edit this. Let me delete the HTML associated with this page, and I'm going to paste the HTML that I got from the other tab. Now, the fact that the application showed up over here, well, that would be true for any application, right? But the existing applications in other frameworks, this would be a dead app. You couldn't do anything with it. You know, you couldn't interact with it any further. But not in Qwik, because it's still an app. You can still work with it. You can still click on stuff, and it still behaves as the rest of the application, because that's actually how the application got from the server to the client. It executed on a server got it to the correct state, server serialized the state into the HTML, took the HTML, sent it to the client in the same way I have grabbed the HTML from one tab and pasted it to the other tab, and it just continues where the application left off on a server or in the other tab. Now, it's a cool party trick, but it's actually useful. Imagine you have a progressive web app. Wouldn't it be nice if you could download the progressive, use it for a while, and then save it, and then when you come back to it, it is exactly where you left off, right? You just continue using the app where you left off from the previous state. Okay, so let's talk a little bit about how other frameworks do things. So this is what I call monoliths. So if you take traditional framework like Angular, React, Svelte, Vue, Web Components, right? The way this works is you server-side send HTML, the browser downloads the JavaScript, and then it starts hydrating on the client. And this is where the blue thing's happening, meaning that we are slowly attaching the listeners, right? And at this point, the application is interactive. And all this work that happened in front is the expensive bit that we're trying to avoid. Now, you can say, well, I'm going to lazy load components, right? All frameworks have mechanisms for lazy loading. And I'm going to show you that it's not actually as useful as you think, because you're still going to bootstrap the code, you're still going to download the application and start bootstrapping, and then you come across a lazy loaded boundary. Well, guess what? As long as the component is visible in the page, you have no choice but to traverse the lazy loaded boundary. So the fact that the developer inserted a whole bunch of lazy loaded boundaries into the application, sorry, you still have to traverse it, you still have to download it, and finish hydrating the rest of the app. So really, in existing frameworks, lazy loading is only useful for components that are not currently on the current page. It is actually not useful for components that are in the same page. Now, we have islands, which is popularized by a framework called Astro. And what Astro does is it says, instead of having one big application, let's break it up into a bunch of small applications. So if I interact with this app, only this app gets hydrated. The problem is that now you have several independent applications on a page, and how exactly are these applications supposed to communicate? One of the things that frameworks solve is component communication. And if your components are now separated by an app, these apps can't really talk in a useful way. So this gets us to Qwik, and the way to think about Qwik is that if I interact with a particular component, then only that component gets resumed. Notice specifically what didn't happen. It didn't force parent components to wake up, and it didn't force child components to wake up. And this is a hard trick to do, because normally when you import a child component, you are importing a static reference to it, and so the bundling system automatically includes the child component whether you want it or not. So even if you don't execute it, you're still including it, whereas Qwik can separate all these things out and keep everything separate. And so the other thing Qwik can do for you is, let's say you interact with this component, Qwik knows like, oh, I woke up this component, but I also understand that there is a relationship between this component and that component. And so if I change this component, I also have to go wake up the other related component and get it bootstrapped as well. And so this is why we call it resumability, right? Because the application can start on the server and continue running on the client as much as you want. Now, what I showed you so far looked like a bunch of separate applications, but actually it's one application. And I can actually show them to you by putting all of these applications in a single page. And let's look at the network tab again. And notice no JavaScript. When I scroll the clock, JavaScript for the clock wakes up. When I start adding items to the component, clicking on things, more JavaScript. When I start clicking on the counters, more JavaScript. And so you have a situation where you as a developer basically don't have to think about it. You just write components. You put them components into the pages, you build apps, you glue things together, and lazy loading is just not in your vocabulary. It's just not something you care about, because it happens automatically by the framework without you having to do anything. And the lazy loaded boundaries become all over the place. Now, you can check out our website, and there's lots of cool stuff over here. But you might ask, hey, wouldn't it be a problem on a slow network that when you click on something, you would have to download things? Well, just like when we serialize the state of the application, we kind of tree shake what's needed and what's not needed. What we can do is we can also figure out what are the possible places where the user can interact, and we can place these possible places as a prefetching code. So if you look at the network tab of this application, and when I click on the button, notice what it responds with. Notice each size says, it's kind of hard to see because the font is large, but it basically says, this is a prefetch cache. Okay, it's not, it's going to show me? No, okay. Take my word for it. The size over there says, this is prefetched already. So when you navigate to a page, it contains a short list of components that are dynamic, that the user can possibly interact with, and that list gets added as prefetching. And it gets better. One of the things we can do is we can keep track of statistics of what is the user's most likely to click on. And when you use that statistical information, then now you can sort the prefetched links and put them in the order which the user is most likely to click on. So if you have an e-commerce site, maybe you put the add to cart button as the first item in the list. And then maybe the logout button is going to be at the bottom, right? And this can all be done automatically without ever thinking about it as a developer. So the mental model here is that most existing web frameworks, they really just care about rendering. and they don't care about who does the bundling, how does the code get to the client, how do you do bootstrap, how do you do server-side pre-rendering. All of these things are kind of secondary concerns of existing frameworks. The thing that makes React different, the thing that makes Qwik different, yeah, sure that's going to be on YouTube. Okay, the thing that makes Qwik different is that Qwik cares about the whole experience, end to end, right? Qwik says, I am in the business of creating a lazy loaded boundaries. I am in the business of bundling. I am in the business of doing server-side pre-rendering. And I am in the business of resumability and making sure that you will score 100 out of 100, right? Qwik makes all of these things its own concern, and for the most part, it solves them in such a way that you as a developer simply don't have to think about it ever again. It just automatically becomes out of the box. And so I think that's the kind of the difference here, is that when you first look at Qwik, you're like, so it's just another front-end framework, and what is not obvious is just how much different the whole approach to the problem becomes, and the end result is that for vast majority of your websites, there just simply isn't any JavaScript to be immediately executed and slowing you down in kind of a startup. Okay, I think I have covered everything, and we have a few minutes for Q&A. So if anybody has some questions, I would love to answer them. Thank you.
Thank you so much for that. Now, we had quite a few questions come in. One of them is, how does this all work on slow networks?
Yes. So that's an excellent question. How does it work on slow networks? And the answer is prefetching, right? So what I showed you is that we put the prefetch links on the bottom, and that tells the system in which order to download. And so even if you're on a slow network, or if you are, if you get disconnected, your application still works. And because the total amount of JavaScript is actually smaller, because Qwik knows what you can and cannot interact with and doesn't even download the code that you cannot interact with, you actually end up in a much better spot.
Great, great answer. And then a question from Carol. Sorry. How is the state protected from cross-site scripting attacks if it's visible in HTML/JavaScript?
Yeah, so it's the same category of like Next.js or anybody else that puts state inside of the HTML. Fundamentally, you trust the server, and therefore whatever the server produces is trustworthy, and therefore you follow it, right? And so it's no different. So same rules apply that you're familiar with. For the most part, Qwik really behaves just like the other frameworks, with the added benefit that you get all this magical tree shaking and data shaking out of the box.
And then anonymous user, they basically say one of the nice things about React and Vue and all that kind of stuff is when you click on something, it feels pretty much instant. Now with let me see. Now, with JavaScript only loaded when the button is clicked, do we go back to this state where things feel longer again?
That's a good question, and the short answer is no. And the reason for that is the startup of a listener, right? When you click on a listener, the startup time is extremely small, because all the client has to do is deserialize the JSON, the state of the system, right? And that's extremely cheap, especially when you compare it to an existing React application that has to do hydration. The deserialization of just state is super, super cheap. That's one thing. The second thing, you can always deserialize the state eagerly, right? So you can always have something that eagerly deserializes the state, and then the click is really no different than any other click. Yeah.
And with the prefetching and all that kind of stuff, you already have the code.
Yes, so you will have equally interactive, quick, responsive application, but you have all these tricks just come out of the box for you.
Nice. Yeah, I really like that you're offloading the time for some of this to happen just to...
The thing to understand is that the amount of JavaScript in the future is only going to get bigger, right?
Yeah.
So this problem isn't going to go away, and so the only reasonable thing to do is figuring out which JavaScript is necessary and which can be delayed, right? And so the whole system is about delaying as much as possible for later.
And yes, another question that gets asked a lot is how can we integrate Qwik and Partytown into Angular? You must get that question all the time.
So Partytown should just work with any existing system, including Angular, etc. So by all means, Partytown is just one of those things that it's just a no-brainer. Go integrate it into your website, and you'll get a, we've seen up to 20-point improvement in page speed score. So that is just a go. As far as integration, one of the things we're looking for is building bridges. We already have a prototype of bridge between Qwik and React, so you can take existing React components and wrap them inside of Qwik and then have them execute. So the use case for that is either you want to migrate existing website, or you want to, for example, use material components widget library in the Qwik website. Now, obviously, within the widget itself, you're not going to get all those benefits, but the rest of the app can do all these tricks. And so it's a form of having a progressive things. And so building bridges is a big thing, and we would love to see other bridges built for other frameworks as well.
Have you thought of using WebSockets to pull in some of the JavaScript?
So far, everything's working fine with prefetching, right?
Yeah.
Browsers understand prefetching. They understand how to prioritize it and how to do all kinds of tricks.
Caching as well.
Caching, etc. And so wherever possible, we're just trying to offload as much stuff to the browser as possible.
Makes sense. And then a question that I feel like you've already answered, but since it was upvoted quite a bit, I'm going to ask it anyway. Tobias asks, does Qwik suggest to the browser or to preload the lazy loaded parts of a component?
Yes, so that's what these links are, right? And the nice thing is these links are computed for you by the framework automatically if you don't have it. And on top of that, you could collect statistical information and further refine these links, right? So this opens up a whole new possibilities. Like one of the problems of existing frameworks is that they give you one, maybe two chunks. And so there's very little you can do with that, right? You really need a rich list of chunks for each of the different components so that you have choices about where you order them, where you prefetch them, what gets loaded when, etc. And without that choice, if you have a single monolithic chunk, your freedom is removed.
Makes sense. And then any downsides of Qwik?
I don't know.
Hasn't been adopted by anybody yet. Oh,
Yes,
not anybody, everybody yet.
Not everybody, but we have several customers. We actually have some customers in production. One of the things Builder does is we have this editor that I showed, and we actually have some people using it already in production because we can just serve up the portion of the site controlled by Builder as Qwik, and the added benefit for them is that the more code they push into the Builder, the faster their site becomes because the less work, React or whatever existing framework they have to do has to do for hydration, right? So it's a form of offloading work.
I feel like when I checked out Builder for the first time, I viewed source on your own website, and I don't remember you using Qwik for your own website. Do you do it now?
We absolutely do. So if you go to Builder.io, this is Qwik website, and it does a couple of cool things. Like my favorite thing is that if you zoom out, half of the page is missing, and if you scroll, it loads everything into it, right? If you go to builder.io/render equals next, this is our old website, and it's the same exact thing. It's just using Next.js. Did I misspell something? No. Why is internet not working?
Oh, there's an I missing. Yes.
Builder. Here we go. And this is the existing website. Let me just zoom out to normal, etc. And this is what I showed you in this demo, how much faster it is on mobile when you have Qwik, right? So you have instantaneous versus not instantaneous, and then of course on top of it we do the tricks with it's below the fold. We're not going to show it to you because you don't need it, and we can start prefetching, etc. So there's a lot of tricks that Qwik allows you to do. Like a lot of these things are things that people have been dreaming about forever. Like, wouldn't it be nice if we could do this or that, etc. But existing frameworks don't really allow you to do that. They don't have the correct mental model. And with Qwik, it just kind of becomes like, yeah, of course, that's just how Qwik works.
Well, I want to thank you so much for this. I think this is absolutely great. Another round of applause.
And I appreciate the crowd for the support, etc. So thank you.
We appreciate you. So we're going to do a quick little break, and then we are going to be back. And we're going to be talking about some more AI. This
By
should
the
be
way,
good.
I'm going to hang out over there. If anybody wants to talk to me afterwards, just come somewhere over there and say hi and accost me. It's fine.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do